Hi, welcome to video 4.5e, even more on integrals. Okay, this is an important one, and this is checking to see if you know the change of limits of integration. So changing limits of integration. Okay, and this is the way the AP will ask the question. They'll tell you what the substitution is, which is kind of obvious anyways. But they'll say if the substitution u equals x plus 3 is made to integrate the integral from 1 to 4 of x plus 3 all squared dx, this integral is equivalent to, and then they'll give you choices, okay? So the idea is you have to sit there and go, okay, if u is x plus 3, then du, sure enough, is dx. You might have to introduce or counteract, but not in this case. And then what you're noticing is all the answers are in terms of u. So the answer is not A, because this is x equals 1 to x equals 4, which is not equivalent to u equals 1 to u equals 4, because u is not equal to x, it's equal to x plus 3. So when x is 4, u is 4 plus 3, which is 7. When x is 1, u is 1 plus 3, which is 4. So the correct answer would be the integral from 4 to 7 of u squared du. Okay, in 87 through 90, solve the differential equation using the initial condition given on the solution graph f of x. So again, old stuff, differential equation, and then they give you this graph, okay? And this is the graph of the solution equation. This is the graph of y. So separate the variables, integrate both sides. You'll let u equal 3x plus 5. Derivative is 3, so I would pull the negative 48 on the outside, introduce the 3, counteract with a third. Of course, bring this up. It'll be now u to the negative 3, which will give you negative 16 integral u to the negative 3 du, blah, blah, blah. Don't forget this will become u squared on the bottom. Don't forget to replace u by 3x plus 5. And now you go back and you go, oh, look, on that solution function, when x equals negative 1, f of x or y equals 3. So you replace the x here by negative 1, and you replace the y by 3, and of course that's going to allow you to find the value of c. C equals 1, and therefore this equation right here, replace C by 1. That is the solution to your differential equation. Number 92, let me just read the directions here. Actually, let me see if I can remove these directions from this page and insert them on the next page. And that so did not work. Okay, oh my, that did not work. Okay, so for numbers 91 through 96, find the area of the region. You will be integrating using substitution, and in some of the questions, you will have to use an extra variable. You're going to evaluate by hand, and then you're going to check it with your calculator. Okay, so here's 92. They tell you this is the graph of y equals x squared cubed root of x plus 2. So of course because the graph is above the x-axis the whole time, the area of that region is the integral from x equals negative 2 to x equals 6 of our function. Now to integrate that, of course, what you're going to do is you're going to let u equal x plus 2, and therefore du equals dx. But now I have this extra stuff here, x squared, so I isolate x here and get x equals u minus 2. Now, while I'm at it, I'm going to change the limits of integration. So it goes from x equals negative 2 to x equals 6. So when x equals negative 2, which is the lower limit, negative 2 plus 2 becomes u equals 0. Take the upper limit of x equals 6, plug it into here. That gives you u equals 8. X squared, of course, is u minus 2 squared because x is u minus 2. And then you have your u to the third du, etc. Again, I would expand, multiply through, integrate, and of course, now that we've changed the limits of integration, you can leave it in terms of u and actually evaluate from u equals 0 to u equals 8. 97 to 102, use the TI to evaluate the definite integral. Easy peasy. But then graph the region whose area is given by the definite integral. So you have to understand that the area, hopefully this graph is above the x-axis the whole time. If it is, then this represents the area bounded by that curve, the x-axis, x equals 0 and x equals 2. So let's graph that function to see what we get, and sure enough, we get this curve right here, which is above the x-axis the whole time. And then so you would draw that and you would shade the region bounded by that curve, the x-axis, x equals 0 and x equals 2. Pretty simple. Okay, evaluate the integral using the properties of even and odd functions. The AP loves this as an aid, okay? And the thing you're going to note is that the limits of integration are opposites. So let's just kind of review. An even function is f of x equals f of negative x. It's symmetric with respect to the y-axis. Therefore, for example, pretend this is symmetric. It's not quite, but pretend it is, okay? If I go from negative a to a, because of the symmetry, the region right here between negative a and 0 will be the same as the area of the region between 0 and a. So the integral from negative a to a for an even function will be 2 times the integral from 0 to a, or from negative a to 0, and therefore, or from negative a to 0. Now, for an odd function, which is symmetric with respect to the origin, then f of x equals negative f of negative x. Now, the areas of these two regions will be the same, but the integral from 0 to 9 will be positive, and the integral from negative 9 to 0 will be negative. So what happens is when you take the integral here, let's pretend the areas of each of these regions is 2. So this integral will be negative 2, this integral will be 2, and when I add them together, I will get 0. Things to keep in mind, y equals sine x is an odd function. As you can see, symmetric with respect to the origin. Cosine of x is an even function. Y equals tan of x is an odd function, again, symmetric with respect to the origin. Finishing up what we just started on the last video. So the idea is to realize that this is going to be, if you know this, okay, but feel free to use a calculator. They won't make it that hard on the AP. But as it turns out, all of the exponents here are odd, okay? So my guess is on the AP, they'll actually give it to you this way. So the fact that it's an odd function, if you're going from negative a to a, it's going to be 0, if you remember. Whereas here, if you rewrite sine x cosine as 1/2 sine 2x, because sine 2x is 2 sine x cos x, so sine x cos x is 1/2 sine 2x. Sine is an odd function. Therefore, if you go from negative pi over 4 to 4, you get 0. Because you're going from negative a to 8 of an odd function. But cosine itself is, so this is a different way of doing it. So if you notice this, then from negative a to a of an odd function is going to give 0. If you don't notice that, let's see if I'm still looking at the same question here. Oh, sorry, number 108, slightly different. Use the symmetry of the graphs of the sine and cosine function as an aid of evaluating each integral. So separate question. So number 108, integrating negative pi over 4 to pi over 4 of sine x. Sine x is an odd function. That'll give 0. Make sure these are opposites of each other. Cosine x is an even function. So it will give the same thing as 2 times 0 to pi over 4. And the integral of cosine is sine. Evaluate that from 0 to pi over 4, and you'll get 2 root 2. Okay? Number 118, the sales S in thousands of units of a seasonal product are given by the model. So this is your number of sales. T is the time in months, with T equals 1 corresponding to January. Find the average sales for each time period. That means find the average value of the sale function. So for the first quarter from 0 to 3, the average value is the integral from 0 to 3. That does not look like a 3, but now it does. Okay, of the sales, because you're finding the average value of the sales, so you integrate the sales function, which they gave to you, all over 3 minus 0, and then you just use your calculator. For the second quarter, would be from 3 to 6. First quarter of the year is the first 3 months, second quarter of the year is the next 3 months, so same thing. For the entire year, it would be 0 to 12. 109 to 110, write the integral as the sum of the integral of an odd function and the integral of an even function. Use this simplification to evaluate the integral. So what they're saying is, notice this is negative a to a. So break it up. Sine is odd, cosine is even. So you break it up. And therefore what happens is So you break up that thing. This is an odd function, so you know this is going to give 0. This is an even function, so the integral from negative pi over 2 to pi over 2 is going to be 2 times the integral from 0 to pi over 2. You're going to let u equal 4x, derivatives 4dx, introduce the 4, counteract with a quarter. You end up with 1/2 sine 4x from 0 to pi over 2. Evaluate that, and after all that, you'll get 0 plus 0, which is a y.